What's up everyone out there? It's your boy Seti of Seti Knows Tech, and I want to first open this video by saying Happy New Year. I hope everyone had an awesome and great holiday season, and thank you for continuing to watch my channel and support the channel. This particular video, I want to talk about something I get questioned with quite often, especially during this time of year when everybody's kind of making New Year's resolutions and they're coming up with what they want to do in the new year, and a lot of times that's centered around career choices. So maybe they're thinking about, starting a new career or getting into something new. And the question is, how can I kind of get myself exposed to or enter the software engineering field? As you know, I'm a software architect. I design and build multi-million-dollar software for major companies and so forth. So I do get questioned about how to get into this field quite often. I get asked like, am I too old to be a software engineer or to try to become a software engineer? They might have children. They say, hey, I have a child or I have children that I want to expose to this field. How old should they be before I expose them? Questions such as, what computer language should I start with first? And just like what concepts should I introduce or be introduced to first to kind of get into this field? And of course, they ask about salaries. What is the expected salary of a software engineer and so forth. I'm a software architect, so I have a lot of experience in this field. I have well over 20 years of experience as a software engineer. So we're going to be answering all those questions and more in this video. But before we get into any of that, you know what time it is. Cue my intro. I often get approached and asked about, what it takes to become a software engineer and things like that. And the first question I ask, the person asking is, what do you think a software engineer is? What do you think it is that we do? And a lot of times I can't get an answer. They're not able to articulate exactly what a software engineer or computer programmer does. They kind of have these, these images of like Mark Zuckerberg from Facebook or Bill Gates from Microsoft, and they understand that they did something, but they're not really equating it to what the actual, what those people actually did to make them software engineers. They just say, I want to be the next Bill Gates. I want to be the next, I want to build the next Facebook. What does that mean? So I'm not into complex definitions and things like that. So I'm gonna keep it real simple. Software engineering or software programming is the branch of computer science that deals with the construction or building of computer software. So what does that mean? Computer software, that's anything that you basically run on your computer or your smartphone and things of that nature. The games, the applications, even the web services that you use, such as Twitter, Facebook, TikTok and things of that nature. Those are all pieces of computer software that runs on computers and servers and things like that. So basically what that means is that there are a group of people, and a lot of them are software engineers or computer programmers, who come together to build those things. And those things is basically computer software. And computer software is not a very linear thing. There's a lot of moving pieces. There's things that kind of fire all over the place. There's front ends, there's back ends, there's middlewares, there's APIs, there's all kind of pieces that kind of make up what a software package is. And that's where computer scientists and computer programmers and things like that, they come together to build that piece of software. So basically that's what software engineering is and computer programming is. So I want to kind of give at least a quick definition of what is computer programming and what does that entail. Computers are very literal in nature. A lot of people think that computers are these super smart things. Actually, a computer is very dumb. And they're very literal and they're very dumb. And it takes people like me to build software that can talk to the computer and tell it what to do via commands. And those commands are very linear, and it doesn't understand a whole bunch of complex operations outside of what we tell it to do. So it's something as simple as, let's say you was building a piece of software for, let's say, how to make a peanut butter and jelly sandwich. That seems simple enough, but to a computer, that is like, what is that? What is a peanut butter and jelly sandwich, yet alone how to make one? So a computer programmer or software engineer's job is to go in there first and foremost and define things such as peanut butter. What is peanut butter? What is jelly? What is bread? and things like that. So you have to create what is known as objects to kind of create those components so that you can actually use them in your program of how to make peanut butter and jelly sandwiches. Then you have tools that you might have to define and utilize as well, such as what is a butter knife? A computer doesn't know what a butter knife is in your program, just arbitrarily. You have to explain to the computer what is a butter knife, and not only what is a butter knife, but what actions can a butter knife take. And those objects are basically known as classes for the most part. And basically a class is an object that you can define what something is, along with things such as functions or actions on what that particular object can do. So for instance, like a butter knife, you can define what a butter knife is, give it some properties or dimensions and things of that nature, as well as some actions that that butter knife can do, such as spread. Whether you can spread peanut butter or spread jelly, because the computer doesn't know what that is until you define it. So it's a very literal process that you have to define software in. And computer programmers, that's what their job is. That's what their job is to build this software in such a way that a computer can understand it and execute the commands that you're giving it to fulfill a task. So that's why I really wanted to kind of define exactly what a computer programmer does and to what degree a software engineer or computer programmer do things, just because that will kind of set the rest of this video on why computer programmers are in such high demand and so forth, and just the things that they do. And inside the field of computer programming, there's a wide variety of jobs or things or functions that a person will specialize in. It's, for instance, like a doctor. Somebody says, you know what, I want to become a doctor. That's great. That's awesome. But nobody just becomes a doctor. You specialize, or you do a particular job as a doctor. I might be a general practitioner, or I might be a surgeon, or I might be a pediatric doctor that specializes with children. The same thing applies to computer programming, or that's the computer program, but when you're talking about computer programmers and so forth, programmers will usually start to specialize, or at least kind of are drawn to particular areas of computer programming, because there's no such thing as just computer programming. There's things such as front-end programming, which is the people who build like the interfaces or what the user will see and interact with on their software. There's people like back-end programmers who handle all the data and the process that's in the back-end, usually on servers. There's API programmers. There's, data programmers, data scientists, people who specialize in just building video games, application programmers, business application programmers. So what happens is, web developers, there's a lot of different areas of specialization, I would call them, that, makes up a computer programmer, and people will kind of be drawn to these different areas in their career, just depending on the kind of person they are or what they just want to do with their computer programming skill sets. Me in particular, I am what is known as a full stack developer. That means that I develop in basically every component of the computer process, our computer programming, our development process. I know how to do front ends, back ends, middleware, and things of that nature. So they will consider me a full stack developer. I can do stuff on the back end as well as the front end. But I do specialize in what is called big data and AI. So a lot of things I develop is around big data, basically housing and managing big data environments, along with processes that can insert data and extract data from those data environments, as well as AI, which is building kind of like neural networks and things of that nature that can do particular jobs or tasks utilizing trained data. And that's a whole nother video that I would kind of get into the various parts of computer programming and things that you might be interested in. But I do want to kind of give you the idea that, it's just not computer programming. I don't want to be a computer programmer. There are areas within the computer programming, science, so to speak, that programmers kind of are geared towards. And those are the things that they do in their career. So often I get, hey SETI, what's the best way to get started with computer programming and software engineering? I want to get started with it. What's the best way for me to get started? Simple. As with anything in life and in general, if you're serious about getting started with a field, especially a field in science such as engineering and computer science and things of that nature, the first thing you want to do is just do some due diligence and research. Kind of, open up the internet, books and things of that nature. Just get an idea of what you're asking to get into before you really start to invest serious time into actually learning that science. because you might realize that, you know what, this is not for me. And that's fine. Computer programming, just like anything in life, is not for everybody. Computer programmers tend to be very, if I had to put some characteristics on it, very logical. And first and foremost, they're very logical individuals. Individuals that, you know, see things in very kind of like logical patterns and things of that nature. And the reason why they are logical is because computers are logical, you know. So we can understand computers because, you know, deep inside, that's kind of how we are, you know. My wife always talk about, you know, said there's, you know, everything does not have to be so logical, but to me, things are very logical, and everything will eventually kind of equate out to a true or a false. I don't see all this gray area and all that kind of stuff. And, you know, that's some characteristics that you might see in computer programmers. Do all computer programmers have this? Of course not. But a lot of them will, and they see things in a very logical manner. They are also very good at breaking down complex problems into smaller problems so that it can build smaller solutions that all interact and kind of interoperate with one another to solve the overall problem. So we start out with a big problem, such as, I know it's not a big problem, but such as making a peanut butter and jelly sandwich. And people like, you know, software engineers and so forth, we just don't say, okay, let's make a program to make a peanut butter and jelly sandwich. That program is broke down into much smaller problems, such as what is bread, what is peanut butter, what is jelly, what is a butter knife, what actions must be taken, you know, the action of spreading jelly, spreading peanut butter, even putting the bread together. Those are all different actions and functions that must be developed and kind of broke apart, so that when we start to put it all together, now we have smaller individual objects, or, you know, depending on the development framework you're working in, components and so forth, that will all interrupt and work together to solve the problem, as simple as making a peanut butter and jelly sandwich. So they tend to be very, you know, people that break down complex problems, can put them back together, you know, quote unquote, fairly easy, very logical people, people who like to spend time with a computer. I spend most of my day in front of a keyboard and mouse. Some individuals say, you know what, I can't do that. And that's fine. You know, some people more outdoorsy people. I'm not an outdoorsy person. I hate the outdoors. So, you know, things like that. If you're not down with, you know, working and, you know, in coding environments and, you know, coding for hours on end, it might not be for you. And that doesn't make you a bad person, or that doesn't make you any, you know, quote unquote dumber or smarter than anybody else. It just means that you're not, your personality traits don't, you're not down with that. And that's one of the things I said, kind of do some due diligence and kind of research computer programming and things of that nature and what it takes, just so that you have a better idea exactly what you're trying to get into and some of the things that you might have to face when you decide to actually ultimately become a software engineer. So I often also get like questions about, you know, when it comes to what's the best way to become a software engineer, is in general, like, okay, you know what? I did my due diligence. I'm good. I want to become a software engineer. I often see a lot of, you know, beginner programmers jump straight into a language. They jump straight into a language like, you know, I'm going to do PHP. So they jump into a language and they start learning PHP and the ways that I do things in PHP, instead of learning the fundamentals and the science of computer programming or software engineering. Software engineering, computer programmers are, you know, the software development period is a science. And with that science, that means there's methodologies, there's, you know, theories and things of that nature that one must learn before kind of taking on languages, so to speak. And because with a language, yes, you can learn how to do certain things. You know, if you're just going to memorize things like that, you know, okay, I need to connect to a database. So you'll go research how to connect to a database in PHP. You'll see it, you'll copy and paste that code, and you might better connect to a database and so forth. But what you're not learning is why. And a lot of reasons why a lot of people get into software engineering and end up quitting is because they never really learn and get a solid foundation of computer science as a whole. Because the truth of the matter is that computer programming, of computer science, and, you know, development in general stays consistent no matter what language you're in. What changes is just the syntax and the way that you might do something in a particular language and so forth. So the theories of programming never changes really. Once you learn them and understand them, they apply across any language you really use. It's really the syntax that kind of change. And the syntax is a formality. You can Google, Stack Overflow and do research on how to do certain things in a language once you understand what you're doing and the reasons why you're doing it. So when you start to construct your piece of software, you're not just trying to memorize, okay, I need to connect to a database, what's that code look like? Or I need to do A, what does that code look like? You start to put together reasons why you're doing these particular things, and you put together that first. Then you go back in, you actually coding. Coding is actually probably one of the last steps that you really do in this whole process. And it's everything else that all the planning and the mindset that you gotta go through to kind of get to that coding phase. So I see a lot of people make that mistake and want to jump directly into a language and learn a computer language so they can just say they know how to do it. And then they end up not being very good at it, or they end up just quitting it because when more complex problems comes up, you never really learn on why are the best ways to do things and the reason why you're doing them. So you end up just saying, you know what, I can't do this, I'm out. And it's just because that's true of anything that's science driven or that's worthwhile. You can't go into say, I'm gonna be a doctor, let me go and figure out how to deliver babies. What? You know what I'm saying? You got to go to school. I'm not saying everybody got to go to school for computer programming, but there's things that you have to learn first. You might, want to learn just basic human anatomy and things to that. You just can't go straight from I want to be a doctor to teach me how to become a doctor that delivers babies and things to that nature. There's a step that you must go through that I see a lot of people who want to get into the programming field don't do. They jump straight to the end result and they end up failing because of that. So that's the first thing you don't want to do is start jumping straight into a language. Learn the principles and the concepts of computer programming, things such as discrete structures, data structures, looping, encapsulations, object-oriented design. There's a lot of things that you must learn first in order to become a software engineer so that you can get into these different languages and do well in them. The next question I get often is, someone who might be a little older, maybe they're late 30s, 40s, maybe, or older. And they ask, what, I want to get into computer programming, but I feel that I'm too old to get started. I see that the younger generation is really kind of controlling these jobs and so forth. Am I too old? That's nonsense. That's nonsense. Just like anything in life, computer programming and software engineering is a direct, kind of correlation with how determined and how much time you're willing to put into it. That's just anything in life, from being a doctor, a lawyer, engineer, anything that's worthwhile is going to take time to get there. So now, would I say if you have an opportunity to start earlier than later? Of course, I'll say start earlier. The earlier you kind of get into all this, not going to say the better, but it just kind of gives you more time to kind of master your craft. But I don't believe for a second that someone says I'm too old to get into software engineering. I'll tell them that's nonsense. If you wanted to do it and you have that passion that you want to get into this, I don't care if you're 70 or plus years old. Do what you got to do to fulfill your passions and the things that you want to do. Because, age is just a number. I know that's kind of cliche, but, age is nothing but a number. And that's true, though. Age is nothing but a number. And that's just with anything in life. If you feel that you have it in you to do this, age is not a factor in if you can be successful in it or not. It's all about determination and how much time you're willing to put into, your gift or your craft. A question I get asked a lot is from parents. A lot of it is, hey, I have a child, girl or boy, whatever, that I want to expose to this field. And the question is, how old should they be before I expose them? That's a fair question. It's a great question. And I would say with that particular question, and I hate to give these kind of cliche or ambiguous answers, but it does come down to your child. Everybody knows, every parent knows their child. And I would say that answer is, it depends if you feel that child is old enough to start to understand some of the concepts. And, some children aren't just very technical savvy, so one of the things you want to make sure that your child is, My child tends to be very logical, and then they are technically savvy. And technical savvy doesn't mean they like to play video games. That doesn't mean nothing. Or they can work my iPhone. That's not technical savvy. Technical savvy is children that likes to tear apart things to see how things work, and they like to they want to know things just beyond what they see on the screen. But like, how does that work on the back end? You got children that asking questions like that. They might be savvy enough to start understanding those principles. Now I will do this. I will give you an age. So if I had to put an age on it, and I had to say, you know what, your child should be at least this age, I'll probably say around 7 or 8. And the reason why I say that is because I'm doing that with my own child. I have a son who is very much like me. He loves technology, and I'm not talking about just playing with the technology. Like when I'm coding, he is just fascinated with what I'm doing. He wants to sit right there and he asks questions. What are you writing? What does those things mean? And he's just he's fascinated with what I'm doing. And I'm not playing games. I'm writing code, and he's in the code with me, trying to figure out what am I trying to write. And that's a game to him, and he loves it. So he's 8, so he's very much like his father when it comes to that. So I've started to teach him the concepts of computer engineering and software engineering. And one of the things I want to say first is the worst thing a parent can do is put their kids in some of these coding camps and expect them to become the next Mark Zuckerberg, in a year. This takes time, and you got to remember that your child is young, and that they're going to learn things along the way as their brain develops and they kind of understand just more things, especially from a logical standpoint. Computer science is a very logical science. It should be. It should just make sense to you why you're doing these things. And to an 8-year-old, what makes sense to them today and what makes sense to them when they're 13 years old will be totally different. So the point of teaching my 8-year-old is not for him to become a computer software engineer now. It's that by the time he's 13, 16, 18, off to college, he will have a strong foundation of what software engineering is. And he might even have some experience building his own software, so that when it's time to, maybe pick that as a career choice, he is, he's upfront and personal with it. I know what I'm looking at. I know what I'm thinking about. I know these different concepts, these different theories, these different methodologies and so forth. And he's just more exposed to it and ready to go. So if I had to put an age with it, I would say about 7 or 8 tends to be a nice age. Or if you got an older teenager, 13-ish, something like that, you want to make sure that they're old enough to understand the methodologies, the concepts, and things that's being presented. And you just got to know your own child. If your child is not a technical savvy person, this might not be the field for them. And again, that's okay. What language should I start with? What computer language should I get started with first if I want to become a software engineer or computer programmer, software developer? This is a question I get questioned quite often with. And like I said, your first step should just be understand the concepts and the theories and the methods and all that kind of stuff of computer science and in particular software development before you try to get into a language. But let's say you did all that, you've done your due diligence and so forth, and you're now truly ready to learn a language. I would say, and this is subjective, you're going to probably get 30 answers from 30 different developers depending on what their backgrounds are. But me as a software architect who develop in a lot of languages fluently, I would say that Python is probably one of the best starting languages to learn. And the reason why is that it teaches you development for a lot of different types of applications. You can actually develop almost anything with Python. That's one. It has you can use it for almost anything. 2, it's a language that's very much in demand. So you learn a skill set that you can actually use to get a job with. Let's say you want to become a Python developer. There's a lot of jobs out there right now, people wanting for Python development, especially in the fields like data science, even website design. There's frameworks and, projects out there like Django and Flask that you can use to build web applications with that are just as powerful as things that you might build in like, .NET Core or PHP or JavaScript, like Angular and Vue.js and all that kind of stuff. So these packages and the Python language itself has packages that you can use for just about anything, and you can get jobs doing a lot of different things with it. It's also very human readable. It's a language that I think Python has done a great job with kind of removing a lot of that syntax barrier or language barrier that a lot of developers will see in other languages such as C++, C sharp, anything that's kind of with these C syntax and stuff like that, that's just not there with Python. It's very human readable. You're able to get into it fairly easily and understand what the code is trying to do. So it kind of gives you that framework of kind of developing software and kind of mastering those skill sets without having that huge, payload and burden of a syntax that you got to do a certain way. And Python, you got to do things a certain way, but it's a lot easier than something like a C++ or something like that. So if I had to put a language on what's the best language to get started with, in my humble opinion, it would be Python. If the next language from there it really depends on what you're trying to do. If you want to become a web developer, for instance, and you say I want to be a web developer and I know Python, what's the next language should I learn? JavaScript. And that's the reason why I say JavaScript is because now you're going to start learning that C syntax type language structure that's in a lot of languages, as well as JavaScript is kind of the glue of a lot of the internet applications and so forth. You can develop mobile apps as well as desktop apps and web applications with this. Some of the most popular frameworks out there right now, which is Angular, React, React Native, and like Vue.js. Those are all JavaScript frameworks and platforms that you use to build your applications and so forth with. So it teaches you front end development very well. You can also Node.js and to build back end development. So if you want to get into web development, JavaScript is a good choice for maybe a second language once you do Python. But like if you want to say, I want to work in the enterprise and I want to work with a lot of companies that deal with Microsoft. I like Microsoft, so I want to build Microsoft technology. Then I would tell you that .NET Core, C Sharp. You can't go wrong with that. C Sharp, you know what I'm saying? So that's why I hope that you're seeing what I'm trying to say, that there's a lot of avenues and a lot of roads you can take depending on the type of developer you want to be and things to that nature and kind of what you want to build, the kind of applications you want to build and so forth. There's always going to be better platforms to do certain things than other things. That's why I spent a lot of my career learning a lot of languages and mastering a lot of languages, because as an architect of a major engineering firm, we build applications that's all across the board. We do things from data science to simple web applications to actual desktop applications and web servers that talk to AWS, all kind of stuff. So depending on what I'm working on, at my average day, I might start off in maybe Python, jump into at lunchtime C Sharp for .NET because I'm working on a Microsoft project, to building something in the back end now in JavaScript or something like that. So but the thing that's consistent across all those is what I kind of told you at the very beginning, is that programming is very, universal. The way things are done, loops, structure, object-oriented design, things like that is very kind of consistent across all the different languages. And the only thing that changes or that differs is the language itself and the syntax. And with the syntax, you can get a Udemy class or, research on Google and Stack Overflow to figure out how those things work, because that's just more formality compared to the overall thing that you're doing, which is software engineering. Boot camps. So you've probably seen by your local college or some online group, they offer boot camps where they say you too can be a software developer in 24 weeks, 32 weeks, or half a year, some short time frame. And they promise you all this stuff about becoming a programmer or developer in a small amount of time. And the question is, I get often is, should I start there? Will that help me? I want to first say this. I don't have any problem with boot camps. I don't. I really think that they have a place in this whole structure and so forth. The only thing I would say about boot camps is that I feel that boot camps, coding boot camps, are for individuals who might have a already previous understanding or a previous history in programming and software development, and they're trying to get up to speed with a particular language or maybe a new methodology or paradigm of programming or just things to that nature. They know how to program already, or they have a strong background in it already, and they try to get up to speed real quick on another platform or another way of doing things. Boot camps are awesome for that particular reason, for that particular purpose, I should say. But for a newcomer going to a boot camp, I'm sure there are people that can do it, and they're that smart and they can do it. But I see a lot of people who enter boot camps raw with no previous knowledge and things of that nature. They come out frustrated and they come out just kind of giving up. And it's no fault of their own. And then what I think, and it's not because of the boot camp. The boot camp is doing their job. Is that it's information overload. It's a lot of information that you're paying for, and these classes are quite expensive. You're paying for these classes, and it's information overload. They got 12 weeks, 24 weeks, whatever they kind of that course outline is, to kind of teach you all this stuff in 24 weeks. I've been doing this for 20 years, over 20 years. And I still, every day almost, I'm on YouTube and things like that, or Udemy classes, watching materials and relearning new things, even things that I already know. Some of the things I do often is look at courses that on languages I already know, just to pick up little new things, that new ways people are doing things. This field is ever changing. It's ever changing. What's hot today and what's the hottest language today will literally be the language that nobody cares about tomorrow, and something else is taking its place. So for a boot camp, you learn all this stuff every day. It's like here's a bunch of concepts, and can the human brain really absorb all that and apply it and reapply it again without being properly trained first to understand what they're trying to apply? I'm sure there are individuals that can do that. The question is that for everybody? So I recommend boot camps for people who might have a prior background or some understanding of computer programming, and they're trying to learn like a new language or a new framework or a new way of doing things, compared to somebody that's cold going to boot camp. I'm sure there's some people that can do that. That's going to be a rough road for a raw person who has no background and prior knowledge of anything. It's just not because the boot camp is doing anything necessarily wrong. It's just of information overload. It's just a lot of information to take in quick to try to apply at a professional level. Salary. Everyone wants to know about the salary. Everybody wants to know about the ducats, the money. How much money can a software engineer make across the board, from starting junior level to your higher end level architect, senior developer, and things of that nature? Before I kind of get into that, I want to first prefix that by saying that it depends on what coast you live on. Of course, West Coast developers probably make a lot more than East Coast developers. Silicon Valley's out in the West Coast, but it also costs 2 to 3 times more money to live out west than it does east. So you have to kind of put that in consideration as well when you're coming up with these numbers. So with that said, is that it also depends on what type of developer you're trying to become. You got your web developers. And you got, like, for instance, web developers versus like back-end developers and data science developers and things of that nature. Me personally, and this is my humble opinion, is that with my career, I tend to make more money as a back-end developer than I did as a front-end developer or web developer. And the reason why that is that a lot of developers, when they come out, a lot of them focus on web development. So there's naturally a larger selection pool to choose from there compared to people that's focusing more on the back-end, data science and things like that nature. So in my examples I'm gonna give out, I'm gonna talk about private firms, because you can work for like the government and things of that nature, but you tend to make more money on the private end. So basically, there's a lot of variables there that depend on how much money you can make. But in general, a junior developer can expect somewhere between $50,000 and $60,000 a year for being a junior developer. Your mid-tier developers, you're looking about somewhere between 60 and maybe 80-ish. You know what I'm saying? And of course, you can make a little bit more, you can make a little bit less, depending on who you work for, how profitable, how big they are, if they're public or private, things of that nature. And your more senior level, software architect level, and things like that, you're definitely looking at 6 figures there. As those type of developers. Again, depending on who you work for, how big they are, how profitable and all that kind of good stuff they are. So in general, developers make pretty good money. It's not an easy field to get into. When I say it's not an easy field, it depends on determination and how determined you are and what you're able to do. But it's a field that takes some skill to kind of get into. So know your worth, know what you're worth to a corporation and the skills that you bring to them, and ask for those salaries. Demand those salaries if you feel that you can bring something to the table that's powerful and unique and so forth. And that's just with any job, but in particular these type of jobs. So anywhere between 50 to 6+ figures a year, depending on what level you are and where you kind of work at, front end, the back end, game developers and things like that. So it's a lot of variables in there of what you can be making, but a 6-figure salary is not uncommon for software engineers. It's not uncommon at all. It's quite common. And that's just because it's a very unique skill set. And with that unique skill set, people, give me what I'm owed. You know what I'm saying? If you do this for your living, you actually either go to school or you do this, got that skill set, know your worth and ask for those salaries. And 6-figure salaries as a senior level or architect level position is not uncommon. So with that said, that is my video. That is what I have to say about, different aspects to think about when you want to become a software engineer or get into the computer engineering field and things of that nature. Like I said, I absolutely love this field. This is who I am. This is all I want to do. So, I get very passionate about talking about this particular field and so forth. And that's why I kind of created the channel and doing this video today. And I just kind of hope that, if you have any questions, please put them in the comments and so forth. And, reach out, and I love to discuss things and, further. If you have a differing opinion, let's talk about it. I love hearing what other people think and things of that nature, because it not only grows my understanding of what other people are going through, but hopefully, you too will get something out of it. Just talking back and forth, stuff like that. So with that said, I hope that you enjoyed this video. If you like this video, please give it a thumbs up, hit that subscribe button. It does help the channel, and hit the bell icon so you know when I release more content to the channel. And as always, first off, Happy New Year. But as always, stay geeky, stay techie. SETI out.